Okay, these are some problems from section 4.6, and these are graphing the reciprocal functions, so of sine and cosine. That's going to be cosecant and secant. So they actually had this already graphed for you using this as our reference function. So I kind of went ahead and graphed it. I kind of started on this problem, but then I had to stop for a second. So let me just kind of get you caught up to where we are. In other words, if we look at this, this is my parent function. So if we have this cosecant, it's the reciprocal function of the sine. So I'm going to have to graph the sine and make it in reference to that. So what I'll do is I'll look at this function over here. I try to figure out the period, and my period is going to be, this is x over 2, so that's going to be the same thing as 1/2 x. So my b would be 1/2. Remember, the period is 2 pi over b, or 2 pi over 1/2. And if I invert and multiply, I get 4 pi. If I want to know each of my subintervals, I divide 4 by 4 pi. I divide 4 pi by 4, and I get pi. So each of my subintervals would be pi. This is my whole period. 4 pi, 1 pi, 2 pi, 3 pi, 4 pi. Each of those is pi. And then I just graph this. Now normally we're going to start at 0. I put my scale like this as -1 and 1, so I can see the 1/2, because I have an amplitude of 1/2 with a negative. So what I would do is normally we would start at 0, and normally we would go to 1, but we're going to multiply that by -1/2, so that's going to take us down here. And then we go back to 0 again, and then normally this would be -1, but we're going to multiply that by -1/2, and that's going to give me a positive 1/2, and then back to 0. So this was your sine curve. Now we're going to graph the cosecant. Now remember, the cosecant is a reciprocal of sine, or 1 over the sine. So every time I have a 0, 1 over 0 is undefined, so that's where I'm going to have a vertical asymptote. And each of these cases will be 0. Now you could always put this back into the original function to see that it is 0. If I put 2 pi into this function, 2 pi over 2 is just pi, and the sine of pi is 0. If I put 0, that again is going to be 0, so it checks out. 0 over 0 is 0, sine of 0 is 0. Okay, so this is my curve. Now I want to check my cosecant, and now this is easy enough to check, you know, for this point, to see where the point's going to be at pi. We know that these are asymptotes, so I know nothing's going to happen there, but what's going to happen here at pi? Well, if I put pi in here just to check it, I have pi over 2, and the cosecant is 1 over the sine. What's the sine of pi over 2? The sine of pi over 2 is 1. 1 over 1 is 1, so that's 1 times the -1/2 makes that -1/2. So I can see that I have a -1/2 here, and in the same respect I would have a positive 1/2, and it's basically just going to touch the top of that curve, or the mount, or the peak. And then the rest is easy. Just graph it like this, and have it hug the asymptotes. So this is all you have to do. So it's always going to be just the peak up here. And like I said, you could always check that just by putting the point in if you're not too sure. And it looks something like that. Okay? And I kind of ran out of room here because I didn't put my graph low enough. I'll try to do that better on the next one. Okay? So let's take a look at number 27. So this is the curve that we want to sketch. So we're going to use its reciprocal function, which is 1/2 the cosine of 2 pi. So first of all, let's figure out what the period of this is. So remember, the period equals 2 pi over b, and my b is 2 pi, so I've got 2 pi over 2 pi, which is just 1. That's going to be 1 radian, so I'm going to be in radians. And if I want the length of a subinterval, remember I just take that period and I divide by 4, so it's just going to be 1/4. So this will be easy to set up. And I'll do it down here a little bit lower so I've got a little bit more room. And make this 1 radian. Remember, that's about 57 degrees. And make this 1 and -1. So there's 1/2 and -1/2. And I'll bring this out here a little bit more. And you'll see why in just a second. And I'll subdivide this into halves, and then halves, so that's 1/2. And that's going to make this 1/4, and this 1/4. Or sorry, 3/4. And I'm going to go one more, so I'm going to make that 5/4. 1 1/4 is 5/4. And you'll see why in just a second. So when we do our cosine, and this is just going to be 1/2, I'm not going to have a negative, so that makes it a little bit nicer. Then normally I'll start at 1. Remember the cosine starts at 1. Cosine of 0 is 1. But then we'll multiply that by 1/2, so we're going to start at 1/2. Then we'll go down to 0. Then we go down to, usually it's -1, but in this case it'd be -1/2. Back to 0. Back to 1/2. And then we continue that over again. So back to 0. So we'll just graph this. And I'll go just a little bit more like this. Although the book went the other way, I think the picture in the book they have this going like this, which is fine. We could do it either way. We could go this direction, -1/4. They just keep going. Okay. So now we have our cosine. Oh, this is a little bit twicked here. We want to get that to curve it down like that. There we go. Okay. And then again, we know, since the secant is 1 over the cosine, every time the cosine is 0, the secant would be undefined. So 1 over 0 is undefined, so I would have my asymptotes over here. So every time I see a 0, I can just draw a vertical asymptote. And then, again, we just hit the top of this, and this is going to be our secant. And again, it just touches the top of that, and you can always check that by putting the point in there. And these are going to be asymptotic to the line. And the reason why we went over a little bit more here, so we could get like a full curve here, because usually we like to see some of these. It looks a little odd, but sometimes they cut them off. Sometimes they cut them off like this, and it does look a little bit odd, but sometimes they'll cut them off like this, so you'll see just, that, and it looks a little strange when you see just this loop here, the whole thing, and down there. Sometimes they'll show that as one period, and for the secant. But this is really what's happening. Okay? So that's pretty much that's number 27. So she gives you an idea what to do. So we have to graph the kind of the parent function or the reference function first, and then the secant or the cosecant after that. Okay? Hope this helped.